All right, in this lesson, we have two goals as we start introducing functions. We're going to be able to determine if a relation is a function and then understand and apply function notation. This is a skill you're going to need through geometry, algebra 2, pre-cal, and on. So by the end of class, you're going to be able to answer these three questions with multiple parts using all of the multiple representations that we have with functions. All right, so first we just need a couple of definitions. The first one is that a relation is a set of input and output values. So when we talk about input, we're talking about x, and when we're talking about y, that's output. So essentially, it's just any set of ordered pairs. So specifically, a function is a relation, so it's just a set of ordered pairs, but every y has one y value for every x value. So if x repeats, in order for it to be a function, it has to give me that same value every time I put it through the function. So this table is just kind of giving you some information about the function notation. So we see it with the f parenthesis x and then some sort of equation, whether it's linear, quadratic, exponential. We're going to deal with all the different functions. We read this f of x. This is read g of x and h of x. So I would say f of x equals 2x minus 3. In all three cases, my input is x. That's what it's telling me. It's a function of that x value. And then the output can either be f of x or y. So I could take this equation and rewrite it as y equals 2x minus 3, which is a little more familiar to us. So if I saw this, f of 3 equals 2 times 3 minus 3. So essentially I've taken this function and it's now telling me instead of inputting any x value, I'm going to put a 3 in. So I put a 3 in and then I would calculate it. The same is true here. If I had g of negative 8, I would simply take that function and where that x was, I would put in the input value and calculate the output at that given input. And same here, I would highly suggest that anytime you replace a letter with a number that you always put it in parentheses. If you notice, I put all of my values in parentheses. We might also see the function notation like this, where it says f of x equals 8. What that means is we're looking for the x value where the output is 8. Because remember we said the output over here is f of x. So it's telling me f of x equals 8. So I would put 8 in and then solve the equation. And we will do more examples of that. I just wanted you to get some notation down with this. So in this class, we're going to have 5 different ways that we represent the same information. So you're used to an equation. I could also put f of x here. I have a table. So for any given x value, if I put negative 4 in, negative 1/2 times negative 4 is 2, and 2 minus 8 is 6. So f of negative 4 is negative 6. And if I put negative 2 in, I get negative 7 out, and so on and so forth. We might see mapping, which is simply taking a table and matching up the x and the y values in this mapping format. It's the exact same as a table. We might see it written as a set of ordered pairs. So the parentheses or the brackets tell me that this is a set of ordered pairs that's representing this function. So it's just taking a table and putting it in ordered pairs. And lastly, we might see a graph, which is a graph of this line right here is simply taking these ordered pairs and putting them on the graph. So these are all interconnected. All right, so our first thing that we're going to do with functions is to be able to evaluate a function at a given value. So if you notice, I have 3 different functions up here. I've got f of x, I've got g of x, and I've got h of x. So we think of a function like a rule. So f of x is saying take x, times it by a negative 1/3 and add 4, and no matter what x value you put in, I'm going to get a specific output. And so a function means I'm going to do the same thing every time to whatever set of numbers. So g of x says take x and square it, multiply it by 2, and then subtract itself. H of x says take the opposite of x and subtract 10. So they're each doing a different rule depending on what the input value is asking. So in this first example where it says f of 6, that means I'm going to be using the f function. So I'm going to be choosing f of x, and it's telling me that instead of x, put 6 in. So I'm going to go to the rule, which says that negative 1/3 times x and add 4. Well, in this case, I'm putting 6 in. So I'm going to take negative 1/3 of 6. So negative 1/3 times 6 is negative 2, plus 4 is 2. So f of 6 is 2. All right, so I'd like you to try example 2 and example 3 on your own. All right, so for example 2, I got h of negative 3 is negative 7, and for example 3, I got g of negative 4 is 36. So if you got different answers, go ahead and look over my work, and if you have questions, jot that down, and we can talk about it in your CSG tomorrow. So now we're going to look at how do I find the input if I'm given the output. So over here, I was given f of 6. So I was looking for what is the output when the input is 6. So here, I know that the output is negative 12. What would be the input? So I'm going to find the correct function. So I'm using the h function. And instead of h of x equals negative x minus 10, I'm going to put negative 12 in for h of x. So I'm going to say the output is negative 12. So what's the input? So now I just have a simple equation to solve. I'm going to add 10. So I get negative 2 equals negative x. And I'm going to divide by negative 1. Divide by negative 1. X is 2, and I'm going to be really picky. We want to write it in that function notation. So f of 2 equals negative 12. So we show that connection. All right, so go ahead and pause the video, and I actually would like you to just try example 6 on your own. So hopefully you got that f of 42 equals negative 10. Again, look over my work, and if you have questions, write those down. All right, so we've looked at evaluating functions when I'm given the actual function. Now we're going to look at evaluating functions when I'm given a table. So this is nice because it's a lot more straightforward. So I'm looking for an example 7, f of negative 3. So negative 3 is my input because it's inside those parentheses. So I'm going to go to the f function, and I'm looking for what is the output when the input is negative 3. The output is 8. All right, go ahead and try example 8 on your own. So hopefully you found that g of negative 4 is 300 because we're looking for the output when the input is negative 4 of the g function. All right, so example 9, see if you can do this one on your own and pay attention. Am I looking for the input or the output? So on this one, hopefully you found that h of 1 gave me 3. So in this case, I wasn't given the input value. I was given the output and had to work backwards. All right, so now we're going to evaluate functions when I'm given it in the representation of a graph. I want you to look at these two graphs. Kind of look funny. This one's called a step function because if you notice it's like a set of stairs. And this is called a piecewise function because it's in different pieces. So I have a linear piece, a quadratic piece, and another linear piece. But we're going to evaluate it the exact same way. We're going to look for that input or output value given the information I have. So in example 10, I'm using the f function, so I'm over here, and I'm looking for what is the output when the input is negative 4. So I'm going to go over to an input of negative 4. That's when x is negative 4. Where does the graph match up? Well, here it is the point negative 4, 1. So f of negative 4 is 1. All right, let's jump down to g of 3. So I'm using the g function, and I'm looking for when the input or the x value is 3, where is the graph? And it's down here at negative 2. So g of 3 is negative 2. All right, g of 6.5. So 6.5 is going to be somewhere between 6 and 7. So it's going to be up here, and the output is 1. So that y value is 1. All right, go ahead and pause the video, and I'd like you to try example 13 and 14 on your own. Hopefully for f of 2, you got 4, and for g of 0, you got -5. We're going to come back to 15. We're going to skip it for a second, but let's look at 16. So f of 3. I like this one because it's a little bit confusing. So if you notice that when I look at f of 3, so it's when the x value is 3, I've got this, and I've got this. Those are all points that are on that 3 value. But if you remember, open circle means it's not part of the solution. Closed circle means it is. So that is the point 3, 3. So the output is 3 when the input is 3 because we're talking about this closed circle right here. All right, so example 17, we are looking for what is the x value when the output is 1, so when the y value is 1. And we're using this g function, so we're going to go when y is 1, what's happening? So I really like this, so we're looking for the x value. Now, what's happening is x is basically, the output is 1 when x is between 6 and 7. So when x is between that 6 and 7, so we're kind of writing a compound inequality, and if you notice, it's closed at 6, so it's or equal to, but it's open at 7. So the output is 1 when x is anywhere between 6 and 7, including 6 but not including 7. All right, I'd like you to try example 18 on your own. So for -2 as the output, that's happening anywhere, anytime that the x value is between 3 and 4. So if you have any questions about that, make sure you write them down for your CSG. And then let's look at example 19. So I'm looking for what is the input when the output is 3. So we're looking right here when the output is 3, and if you notice, it's happening right here, and right here. So there's actually 3 x values. Output is 3 when x is like -1.8. We're just going to estimate. It's not quite to -2. I'm sorry, it's not quite to -2. It's just a little bit before. It's also happening right here when it's not quite 2, so it's about 1.8 positive. And it's happening here when x is 3. So the output on this graph, there are 3 times when the output is 3, at about -1.8, 1.8, and 3. All right, so example 15, I'm going to leave as kind of a challenge problem. So go ahead and see if you can figure out all the x values when the y value is 1. See if you can write that. All right, so the first part of our objective, understanding what a function is, understanding multiple representations of a function, so the graph, the equation, all of those interact, and evaluating a function for a given value. We've done that. Go ahead and have an interaction in your note. So off to the side, what makes sense to you? What questions do you have? What picture would help you remember? What analogy? Where are you confused? All of those things, that's where you write those in your notes now. All right, so another part of our objective is to be able to compare properties of functions. So we're going to look for which is greater or smaller when a certain x value is given. So on this first example, I'm looking for which function is larger. So the output is larger when x is -2. So I'm simply taking my f function and finding out what the output is when x is -2, and I'm going to take my g function and find out what the output when the x is -2. All right, so when I plugged -2 into both of the functions, I was able to find that g of x is larger because it has an output of 12, whereas the f of x is -3. All right, so go ahead and pause the video and try example 21 on your own. So hopefully you were able to find that at an input of 4, f of x is going to be smaller because its output is -21 versus 6. So our last goal is to be able to determine if a relation is a function. So remember, a function is a relation, so it's a set of x and y values that has one output value for every input value. So if my x repeats, I get the same value. That's the definition of a rule or a function. So in this case right here, in this mapping, I have -2 that's pairing to 10, and I have -2 that's pairing to 14. I also have -8 that's giving me 5 and -5. And I have -10 that's giving me 7 and it's giving me 0. So if you think about one output for every input value, all three of these inputs are giving me multiple outputs. And there's no way that I could plug -8 into a function and get two different values when I do it. So that means that this is not a function. And it's not a function because -2, -8, and -10 all have multiple outputs. Which goes against what the rule is, one output for every input value. All right, so let's look at example 23. I'd like you to see if you think it is a function or not and why. So hopefully you were able to determine that this is a function. You may have noticed that -5 does repeat, but when I put -5 in the first time, I got 10 out, and when I put -5 in the second time, I also got 10 out, which follows the rule of one output for every input. So if the x value repeats, it has to give me the same value as the outputs. All right, so looking at a mapping or a table, I can tell by looking at those input and output values. But how can I determine if if a relation is a function from a graph? Well, a graph is kind of one of the easiest because we're looking for what's called the vertical line test. So if it passes the vertical line test, then it is a function. If it fails, then it's not a function. And the reason that we use a vertical line is because we said for every input, there's exactly one output. So as I run my pencil or my ruler across this function, so as I run it vertically across, is it crossing more than one y value for every input? So if you notice, as I run a vertical line across here, it's only going to touch that function and give one output for any input. Versus this one over here, when I run this vertical line, let's say right here, the input is 2, and when the input is 2, I get -2 as an output, but I also get 6 as an output. And so the definition of a function is that I can only have one output value for every input value. So this is not a function. Because as I run that vertical line across there, it touches two places, which means it fails. This one is a function. Because it does not, as I run that vertical line across there, it does not touch in more than one place. All right, so we have now done all things functions. So what I'd like you to do is look at these sub-objectives and think about what you understand and where you have questions and have an interaction. So what makes sense? What questions do you have? What do you want to talk about tomorrow in class so that we can make sure that your understanding is solid?